Welcome back. I always get excited to jump back into our deep dives into the Lucasian Professors of Mathematics.
Oh, me too.
And this is our 15th episode, so we've really covered some ground so far.
Yeah, we have. It's amazing to think about the sheer intellectual firepower that's occupied that chair over the centuries, isn't it?
It really is. And today, we're going to delve into the life and work of the 14th holder of this prestigious position, Sir Joseph Larmor.
Ah, Sir Joseph Larmor. A fascinating figure, to say the least.
Yes, he was. A pioneering figure in physics and mathematics from the late 19th and early 20th centuries. We've got quite a collection of stuff to work with, too.
We do. Biographical information, scientific papers, even some personal anecdotes that give us a real glimpse into who he was as a person.
So we are going to try to paint a picture of this complex figure, someone who not only made groundbreaking contributions to our understanding of electromagnetism, but also navigated the turbulent world of politics and even challenged some of the most famous scientific minds of his era.
Sounds like a real challenge.
It does, doesn't it? But that's what makes these deep dives so interesting. So where should we start?
Well, how about with his background? I always find it interesting to see how someone's early life might have influenced their later successes.
Me too. And Larmor's journey from humble beginnings in McGirragall, County Antrim, to the hallowed halls of Cambridge is quite remarkable.
It really is. I mean, think about it. Born to a shopkeeper and his wife in a small village in Ireland, and he ends up becoming a Lucasian professor. That's incredible.
It's inspirational, to say the least. He excelled at Queen's College in Belfast before heading to St. John's College, Cambridge. And that's where something truly remarkable happened.
Yeah, tell me more.
He beat J.J. Thomson to become senior wrangler in the 1880 mathematical tripos.
Wow.
Right. To top the class in one of the most demanding mathematical exams, surpassing someone who would later win a Nobel Prize.
It's a testament to Larmor's early brilliance. I mean, to be that good at math at such a young age.
It really is.
And then the story gets even more interesting. While J.J. Thomson is credited with discovering the electron in 1897, Larmor was already referring to the particle generating electric charge as the electron as early as 1894.
Wow, so he was kind of laying the groundwork for one of the most important discoveries in physics.
Precisely. You could almost call him the electron's architect. It's fascinating, really. It makes you think about how some discoveries are the culmination of contributions from multiple people.
It does make you wonder, doesn't it? What would physics look like today if one or the other of them hadn't made their discoveries?
Big question, who knows? But it's something to ponder. Anyway, getting back to Larmor, he is perhaps best known for his work on the Larmor formula.
Yes, the Larmor formula. For our listeners who are deep into STEM, I think we should spend some time explaining this. What is it, and why is it so important?
Well, in essence, the Larmor formula calculates the power radiated by a non-relativistic accelerating point charge.
Okay, I think that might need a bit more explanation.
Sure. Maybe an analogy might help.
I think so.
Imagine a speedboat racing across a lake.
Okay, got it.
As the boat accelerates, it creates waves in the water, right? The faster it accelerates, the larger and more powerful the waves become. Now, replace the boat with a charged particle, like an electron, and replace the water with an electromagnetic field. So as the charged particle accelerates, it creates disturbances in the electromagnetic field, just like the boat creates waves in the water.
I'm seeing it. So those disturbances, those are what we perceive as electromagnetic radiation, like light or radio waves.
You got it. And the Larmor formula, that's what lets us calculate the power of that radiation, how much energy the accelerating charged particle is emitting.
That's incredible. So this formula, it became so crucial in physics because it essentially allows us to quantify something as fundamental as electromagnetic radiation.
Exactly. It's crucial for understanding how energy is lost by accelerating particles. Like, it helps us understand why particles in a particle accelerator lose energy as they speed up, a phenomenon known as synchrotron radiation.
Oh, I've heard of that. So this seemingly highly specialized formula actually has very real implications in various scientific fields.
Absolutely. From astrophysics, where it helps us understand the radiation emitted by stars and galaxies, to medical imaging, where it plays a role in developing advanced imaging techniques, a real testament to theoretical physics.
It really is fascinating. I love how we can trace the impact of theoretical work like Larmor's on such a wide range of scientific applications.
Me too. And speaking of Larmor's work, he also made significant contributions to our understanding of the very nature of space and time.
Yes, his magnum opus, Aether and Matter, published in 1900, explores that very thing, right?
Right. But to understand it, we need to go back a bit. Back then, scientists believed in the existence of the ether. You know, the idea that just like waves in the ocean need water to travel, light needed a medium called the ether to propagate through space.
Okay, so where does Larmor's work fit into all of this?
Well, he was building on Lord Kelvin's work, specifically his model of spinning gyrostats. Larmor proposed that the ether could be represented as a homogeneous fluid medium, and he used this model to explain various phenomena, including the propagation of light and electromagnetism.
Wow, so he was essentially trying to explain the very fabric of the universe.
In a way, yes. Aether and Matter really delves into that, and that's where it gets even more interesting. He independently derived a set of equations, the Lorentz transformations, we call them now.
Wait, those are the equations that are central to Einstein's theory of special relativity, right?
Exactly, and he came up with them around the same time as Hendrik Lorentz, and years before Einstein published his work in 1905.
So he was right there on the cusp of this huge scientific revolution.
You could say that, but here's the thing. He remained a staunch supporter of the ether theory, even after Einstein's theory of relativity started gaining traction.
That's interesting. It seems a bit contradictory. He makes these significant contributions to physics and mathematics, yet he stays tied to this outdated concept.
Yeah, it does, doesn't it? Science is rarely a straightforward path, and even brilliant minds can be resistant to change, especially when it challenges long-held beliefs.
You're right about that. And that's what makes this whole story so interesting to me. It's like, how can someone be so brilliant and yet still kind of, I don't know, blinded by their own preconceptions? It makes you wonder what might have been.
Right, like what would have happened if he had embraced relativity earlier? Would his contributions have been even greater? It really raises questions about the nature of scientific progress.
I think it does. But you're right, his work on the Lorentz transformations, even if it was within the framework of ether theory, it was groundbreaking.
It was. You can't take that away from him.
It really helped lay the mathematical foundation for special relativity, even if Larmor himself didn't fully grasp its implications at the time.
He was so close, yet so far.
It seems like we've only scratched the surface here. There's still his political life, his later scientific work.
So much more to unpack.
Yeah. His story is a perfect illustration of how science doesn't always follow a neat, predictable path.
And how brilliant minds can still have their blind spots.
Well, this is shaping up to be a fascinating look into the life and work of Sir Joseph Larmor.
I think so too. It's a great reminder that even groundbreaking discoveries often involve contributions from many different people, and that scientific progress is rarely simple or straightforward.
Well said. I can't wait to dig deeper.
You know, it's just amazing how someone can be so ahead of their time in some ways, and yet so rooted in the past in others.
I know what you mean. It's that push and pull, that tension between the old and the new, that makes Larmor such an intriguing figure.
Exactly, and nowhere is that more evident than in his relationship with Einstein and his views on relativity.
That's right. This is where we see Larmor's deep commitment to the ether theory come into play, even when faced with growing evidence that challenged its validity.
Yeah, he never really came around to Einstein's concept of curved space, or the idea of relative time, for that matter.
He just couldn't let go of absolute time and space. They were like cornerstones of his understanding of the universe.
Exactly. He held on to the idea that time was absolute, independent of any observer, essential for astronomy, and accurately measuring celestial events. It's like he couldn't quite wrap his head around the idea that time could be relative.
I see what you mean. It's fascinating, isn't it? How deeply ingrained certain scientific concepts can become, even when new evidence challenges them. It can be really hard to let go.
It really is. It speaks to the human side of science. You know, it's not always just about cool, hard facts.
Absolutely. There's always that element of personal belief and bias, emotional attachment to certain ideas.
So how did all of this manifest itself? I mean, did Larmor's skepticism towards relativity hinder his work in any way or influence his research?
Well, it might seem like it would be a roadblock, wouldn't it? But actually, his skepticism led to some really productive back and forth within the scientific community. His challenges to Einstein's ideas actually forced others to really think them through, refine their arguments. So it kind of helped make the theory stronger in a way. Like iron sharpens iron.
Exactly. It pushed people to address his concerns and ultimately led to a more solid understanding of relativity. It's a testament to the power of intellectual debate.
It is. It shows how even opposing viewpoints can contribute to the advancement of knowledge.
Couldn't have said it better myself. Okay, now let's step outside the realm of pure science for a moment.
Okay. Where are we headed?
Let's talk about Larmor's foray into politics.
Right. He was strongly opposed to home rule for Ireland, wasn't he?
He was. He believed in the importance of a unified United Kingdom, and he had serious concerns about what might happen to Ireland if it gained independence.
This was a deep-seated conviction for him, something he felt strongly enough about to enter the political arena.
Absolutely. In 1911, he actually became a member of parliament for Cambridge University.
Wow, that's a big step, to go from the world of academia into the messy world of politics. It really shows his commitment to his beliefs.
It does. And it challenges that stereotype of the scientist as this, detached observer. It shows that they can be engaged citizens with strong convictions about the world around them. Larmor certainly was.
No doubt about it. He wasn't content to just sit in his ivory tower. So let's talk about his role as Lucasian Professor. That's a position that's been held by some of the most brilliant minds in history. What kind of impact did he have during his time in that role?
Well, he was appointed to the Lucasian Professorship in 1903 and held the position for almost 30 years.
30 years, wow.
Yeah, quite a legacy. He retired in 1932. And during his time, he was a dedicated teacher, a mentor to a whole new generation of mathematicians and physicists. But his contributions went beyond the classroom. He was a meticulous editor of scientific works.
I've read about that.
Yeah. Think about it. He took on the huge task of editing the collected works of giants like Stokes, Thomson, and Lord Kelvin.
That's a massive undertaking. Must have been a real labor of love. I mean, their work is incredibly complex and influential.
It was. And it really speaks to his respect for these pioneers of science. He wanted to make sure their knowledge was preserved and accessible to future generations.
That's amazing. I mean, he understood that each new discovery builds upon the foundation laid by those who came before. He was really a custodian of scientific knowledge, passing the torch, so to speak.
Exactly. He saw himself as part of this long chain of scientific inquiry, And it's a good reminder for all of us that scientific progress is a team effort.
It is. Okay, let's get back to Larmor's scientific work for a moment. I want to talk about his later work, specifically his proposal about sunspots back in 1919.
Oh, yeah, the sunspots.
Yeah. What was that all about?
Well, he proposed this idea that sunspots are like self-regenerating dynamos, happening right there on the surface of the sun.
And this was a significant contribution, right?
It was. It really helped us to understand the dynamics of the sun, laid the groundwork for future research in solar physics.
So even as he got older, he was still contributing to all sorts of scientific fields. Just incredible.
He never stopped learning, never stopped asking questions. It's inspiring, really.
It really is. Okay, so we're starting to get a picture of this really complex, influential figure. A man who, even though he held on to outdated ideas like the ether, still made really significant contributions to our understanding of electromagnetism, the electron, and even physics as a whole.
I agree. He reminds us that scientific progress isn't always a smooth, predictable journey. It's full of twists and turns.
Yeah, and it's those twists and turns that make studying the history of science so fascinating. It's about more than just learning facts and figures. It's about understanding the people behind the discoveries, their struggles and triumphs.
Couldn't agree more. And Larmor's story is a perfect example of that. He was brilliant, stubborn, made mistakes, had breakthroughs. He was human. And that's what makes him so interesting.
Well said. I'm ready to dive into the last part of Larmor's story. It's really quite remarkable when you think about it. How Larmor's skepticism towards relativity, which you'd think would be a hindrance to scientific progress, actually helped solidify its foundation.
It really does show that even when challenges are rooted in ideas that are, outdated, they can lead to a more rigorous examination of the new ideas and ultimately make those new ideas even stronger.
His insistence on questioning Einstein's theories, it really forced the scientific community to address his concerns. And that led to a more thorough and complete understanding of relativity.
It's a great example of how important open dialogue and debate are to the scientific process. It's not about blindly accepting new ideas. It's about critically evaluating them, challenging assumptions, making sure they hold up under scrutiny.
So in a way, you could say that Larmor's resistance, his skepticism, actually contributed to the progress he seemed to be resisting. It's a bit ironic, isn't it?
It is, but it's also a reminder that scientific advancement is rarely a smooth, linear process. There are going to be bumps along the way, disagreements, wrong turns. That's all part of it.
And speaking of bumps along the way, let's go back to something we talked about earlier. Larmor beating J.J. Thomson to become senior wrangler in the 1880 mathematical tripos.
Ah, yes. That's a story for the ages. It really shows you just how incredibly talented he was in mathematics, even at a young age.
To accomplish something like that, it takes an incredible amount of intellectual horsepower.
And remember, he didn't come from privilege or a family with a background in academia. He started from humble beginnings, had to work hard, and prove himself every step of the way.
That makes his achievements even more remarkable, doesn't it? It's an inspiring story, really. Shows that brilliance can come from anywhere, and that with dedication, you can achieve great things no matter where you start.
It's a good message, especially for anyone who might feel intimidated by science or doubts their own abilities. Larmor's life is proof that you don't have to be born a genius to make an impact on the world.
You just have to have the curiosity, the passion, and the drive to keep learning and keep asking questions.
Well said.
So as we wrap up this deep dive into the life of Sir Joseph Larmor, I think it's safe to say that he was a truly remarkable individual.
He was. Brilliant mathematician, a pioneer in physics, a dedicated educator, and yes, a bit of a controversial figure who wasn't afraid to challenge the status quo, even when it meant going up against some of the greatest minds of his time.
His story reminds us that the history of science is full of these complex characters, these brilliant minds who help shape our understanding of the universe. And sometimes those brilliant minds made mistakes or clung to old ideas, just like the rest of us.
Yeah, Larmor might not be as well known as, say, Newton or Einstein, but there's no denying his impact on science.
No denying it at all. His work on the Larmor formula, his explorations of the ether, his derivation of the Lorentz transformations, and of course his dedication to preserving the works of other scientific giants, all of that has left a lasting mark.
A really important reminder that science is a collaborative endeavor. It's a journey of exploration and discovery that's built on the work of countless individuals, each adding their piece to the puzzle.
And Sir Joseph Larmor, with his unique combination of brilliance, persistence, and, let's face it, stubbornness, deserves his place in that story.
Absolutely.
Well, we've covered a lot of ground today, and I hope you've enjoyed this deep dive into the life and work of this fascinating and complex figure.
Me too.
And maybe, just maybe, it sparked a little curiosity in you, made you want to learn more about the history of science and the people who shaped our understanding of the world around us.
I hope so.
Until next time, keep exploring and keep those questions coming.